Okay. There we go. Now, the first thing we want to look at is a bar graph. Now, a bar graph is a graph that relays information using bars of various sizes to indicate values. Kind of self-explanatory, yes? A bar is a bar graph. So we can have it horizontal or vertical. So here we have them horizontal or vertical because they're going up and down. Here we have them horizontal. And they're giving the same pieces of information. The next type we can have is a line graph. It's a graph that relays information through individual points that are connected to each other on a line graph. And a table, a non-graphical way to relay information about a system in which columns or rows are used to display data. Because any type of chart can always be represented as a table. Where here we're looking at the X and Y values. So, what are some relationships? I mean, it asks about that there. So, one scientist, let's look at this here. One reason scientists investigate these relationships is that understanding relationships allows people to make more informed decisions about a situation, where we can better understand what is the data actually telling us. How is it relating to each other? Because the better we can understand the relationship between the data and what it's telling us, the better we can understand what it means. Because just having numbers and having a meaning from it are two separate things entirely. One of the biggest things is it can be very misconstrued with numbers and data, because one of them is with time in the classroom, because they talk about spending the last 3 minutes of class is wasted, because if we don't do anything the last 3 minutes, it's just 3 minutes. But if we look at across 5 days, well, that 3 minutes is now 15 minutes. 4 weeks in a month, well, that 15 is now 60. So essentially, you've wasted an entire hour by 3 minutes. Well, it's easy to look at that huge number and think, okay, that doesn't have any meaning. But if we look just at the number or the individual data, it could be a whole different interpretation of it. Because an hour is a lot, but if we are done with the last 3 minutes, there's nothing we can add. So it's not really wasted, it's utilized elsewhere. Now, when we look at this here, imagine you're driving in an unfamiliar area. When the vehicle's gas light comes on and you do not know when you will find a gas station. Yeah. Do you think it would be more beneficial to drive as fast as the car can possibly go at a moderate constant speed, or in a slow stop and go intervals? What do you think would be best to try to get to the next gas station? Drive as fast as the car can possibly go? Yep. So stop and go wouldn't work either, because you'd be wasting gas, because you'd have to speed up and slow down, speed up and slow down. So constant speed would work better, because there is a direct correlation between velocity and gas mileage, yes? Now, another example kind of this here, and we'll get to the charts here in a second, is we can also have a relationship between the age and size of a baby, yes? Why do you think understanding this relationship might be important? Right, if they're not growing right, because there are set tables that they should be meeting, or y'all should be meeting certain height and weight markers by certain ages, because it might indicate some very health issues down the road if you're not meeting those marks. And especially dropping from the top to bottom is very worrisome. So where if you're at the top percentage in your height and weight, so you're above the average when you're 10, but then by the time you hit 12, you're in the bottom 10%. is not a good way to go. Now, so a herd of dairy cattle was given various amounts of forage, dry matter, and grain as a percentage of their body weight, and their average milk output was measured. So what do we think the relationship between these would be? Right, because when the forage dry matter intake increased from 1 to 1.2 to 1.4 and the grain intake increased from 1 to 1.5 to 2, the average milk output did increase. So we can say that the amount of food intake increased the amount of milk input, in milk that came out, yes? Can we say which one had a bigger impact? Well, no, right? Because is there any data telling us about the overall impact that the dry food or grain intake had? No, we just know that the increase in both had an increase in overall production. Experiment 2. Move the laser. 3 herds of dairy cattle were each fed a constant amount of forage dry matter and a randomly assigned percentage of grain. Each herd's average milk output was measured. So what can we say about the relationship for this here? Mm-hmm. Right. And we can say that as long as the amount of dry forage, the forage dry matter, did increase or decrease. Do we know if it increased or decreased from A to B to C? And it was a constant and a randomly assigned proportion for grain. So yes, actually I take that back. Yes, we could say that it did help more a little bit here and there, because as the grain went down, the amount of average milk went up, yes? Yeah, and that is, at this point, a well-known fact, because if y'all have ever watched Food Inc. or any of those kind of deals, they show that cows cannot handle large portions of grain or wheat or corn. Mm-hmm. Yeah, they just can't. Grain is not healthy for them. But again, a lot of this is just seeing the connection between these. Let's see here. So we have current and water temperature. Discuss the relationship between the different columns with the class. So table 1. So we have trials, current, and distance. So what can we say about that? Mm-hmm. Do we really know what we're talking about with current and distance? Does it really matter what we're talking about? No. But as the amperage increased from 5 to 10 to 15, the overall distance went down. So that's what we can see from here in the table. As this increased, this one decreased. Let's look at table 2. So we have water temperature and blue-green algae cover. Well, did we get anything really from trial or lake? No, not really, unless we are given more information. But here, really, we're just looking at water temperature and blue-green algae cover. So what can we say about it? Yes, as the temperature increased, the amount of algae that was covering the pond went up. And that's all we have to say. So this here, so the table and line graph, do both represent the same data? Yes? Now, this line here that is given on the chart is what we call a line of best fit. A line of best fit, because does it actually intersect at every single point on the chart? It ends up intersecting something close to it, because we need to because to get an actual line, an actual equation would not work well for this, because the lines do not completely line up to where they're supposed to be. Now, we get something similar. Now, is there a trend in how the points on the graph go? Where are they going? Down. So they would be decreasing. Now, they're not decreasing at a constant pace, but they are decreasing from one to the next, yes? So the average change would be decreasing. And we can see that in both the table, because as the time passes, it increases. The temperature is decreasing. So what can we say about this here? As the time increases, the temperature is increasing. Now, it increases fast at the start and then slowly decreases as it goes off, but it is still increasing over time. So sometimes ACT requires or uses complex figures that require critical thinking. For example, two variables might initially appear to be related until data illustrates that changes in one variable do not necessarily cause changes in the other. An extreme example of this is presented in the next graph to help us kind of see this. From figure 1, it appears that as the number of pirates has decreased, the average global temperature has steadily increased. Do you think that this data here has a direct relations or inverse? Do you think they're both going up at the same time, or kind of inverse would be opposite? Does the number of pirates have anything to do with the average temperature? No. They gave us this data here kind of showing us this, but do they really relate to each other? Well, no, because they don't go together. They are not connected to each other. But they do give us this chart kind of showing us the two together, but they don't have any real connection to each other. They just put them together. Here, what are they comparing? And again, this here is just trying to reiterate they will put some things together that really don't have any connection to each other that we're comparing, but they will still put them both in the same chart. So we've got to be careful when we're looking at this to make sure that we're actually reading the correct thing and looking at the correct pieces of information.